Right, let's solve this system right here. Now the first equation there, y equals x, it tells us that whatever y or x is, the other is the same. Okay? So y equals x tells us that if we find a y value that's 5, x is going to be exactly 5 as well. That's the only values that we could use to make this equation true. Now this one, it does set up as y equals, or you could say x equals, but I'll show it as y equals x right there, which means that I'm going to go to the other equation, and I'm going to take the 3x plus 9y equals 24 and replace the y with the x. So this would give us 3x plus 9x equals 24. And I don't really need those parentheses because it's just being multiplied by the x. So that's our new equation after replacing the y with the x. And from here we can solve 3x's plus 9x's. That would be 12x's. This will equal 24. And last thing we want here for the x is a coefficient of x that's a phantom 1. So we'll do that by dividing both sides by 12. And we get x is 24 divided by 12 is 2. So in our ordered pair, we now have an x value that is 2. So if x is 2, again up here, the only value of y that would make this equation true if x was 2 is if y was 2 as well. So down here we can put y is 2 also. Now would that make it true if we replace the x and y with 2 in this equation? Well, 3 times 2 is 6, plus 9 times 2 is 18, 6 plus 18 is 24, and that means we've checked this equation, and then of course 2 equals 2, and we can check off the first one. Here's our objective for the day. I can solve a system that has inequalities. So take 30 seconds, copy that down, then we'll get started. All right, today we're going to be solving a system that has inequalities. So we're going to need the graph on these. We will not be able to just write one individual ordered pair for this. We're going to have to show the solutions on a graph just like we were doing before. But since it's a system, instead of putting just one line on the graph and then one set of shade, we're going to have 2 lines on the graph and then shade 2 parts. So we'll take a look at that, but take 30 seconds, copy this down. So this is all stuff that we've seen before, but a solution to a system of inequalities, it's not just an individual location on a graph like we've seen not just on the bell work, but pretty much in the rest of this unit. We don't want just one ordered pair to represent it because there's going to be an infinite number of solutions for these systems of inequalities. Now in graphing a system of inequalities, what you may end up with is maybe a line like this one. And we'll pretend like I'm good at drawing and that this is a straight line. Either way, in the past we've seen lines come out of inequalities like this that are solid lines. Sometimes though they can be dashed. So it is possible in the past that we may remember or have seen something like this one. Now the difference between these two is very important, because a dashed line like this one indicates that the values on the line would make that inequality, wherever this came from, false. So this line represents the equality part of the inequality, but then if we remember, in the past we had to do some shading. So we would say, you know what, I'm going to shade maybe below the line. Now that would come from testing a point. In the past we tested the origin. And if it were true, then we shaded this side of the line. And if it were false, we would have shaded the other side of the line. So we went through this with one line, and then we would get something that looks like this. But in addition to that, we may also have needed to graph another line like this one. Okay? Now this line would come from an inequality. And if it had the equal part of an inequality, we would keep it a solid line. I'm just going to keep it solid for now. And when we were graphing in the past, ordered or equations, we just graphed the 2 lines and then we found where the 2 lines intersected, and that was our solution, just like we saw in the bell work. And we found that you could use graphing to solve those. You can use elimination to solve them, or like we did on the bell work, you could use substitution. But with inequalities, it's different because Now the red, all this red shaded area here would represent values or ordered pairs that would make the red inequality true. So if we're doing this for an inequality like we just did here for the blue line, then we would test, again, the origin here in the middle at 0, 0, and see if it's true. Now if it were true, we would shade this side of the line. If it were false, then we would shade the other side of the line, and so it would maybe look something like this. But what we end up with is we have 4 different areas on the graph now. We have this area, which has no shading at all. What this means is that any ordered pair in this area, like maybe this one right here at 8, 4, would make both of these original inequalities false. If you looked at any ordered pair in this area that's just shaded red, it would make the red inequality true, but it would possibly make some of the blue inequality. Yeah, it would make the blue inequality false there. If you look at this area, which is only shaded blue, it would make only the blue inequality true, but it would make the red inequality false. What we're looking for is the area that's double shaded, like we see here, because this shows red and blue shading, which would indicate that it would make both inequalities true. So we generally, when I do it, I like to shade it a whole different color, like this. So yeah, one of them was red, one of them was blue. So I shaded it purple, but I won't always be able to do that because I just don't remember to. But any ordered pair in this location, in this area, would make both inequalities true, wherever these came from. So you could try this point at negative 5, 5, and would make the red inequality true and the blue one true. We need truthfulness for both, but we only need to test one point for truthfulness or falsefulness to just figure out where we're going to be shading. So we'll demonstrate that this has infinite solutions with this shading stuff, this system of inequalities, instead of just having one solution. So on the assignment, you'll see problems like this one. It just wants to know, we're looking at 2 ordered pairs. We got negative 12, 5, and then we got 0, negative 1. It's just asking, is this ordered pair a solution to the system? Now, if it is a solution to the system, it has to make both, not just one, but both inequalities true. So if I find that it makes one of them false, then automatically it would be not a solution for the system. So I'm going to start with the first one there. We got y is less than or equal to negative 2/3 x minus 2. So I'm just going to write this down. Y is less than or equal to negative 2/3 x minus 2. But we're given an x and a y value from the ordered pair. So the x value is negative 12. So I replace the x here with negative 12. And the corresponding y value is 5. So I put a 5 in here. Now I don't know if this is true or not, so I'm just going to put a question mark here just to see if it's true. There's nothing to do with the 5, but we want to see if 5 is less than or equal to, let's see, negative 2/3 times 12, that'd be 8 minus 2. I get 6. 6 right there. So is 5 less than or equal to 6? The answer is yes, it is. So this statement is true when, that means the original inequality, this one, is true when we replace the x with negative 12 and the y with 5. So it makes the first equation true, but it has to make both equations true. We can't just check in one, we got to check in the other as well. So the second equation, y is greater than or equal to negative 1/2 x minus 1. And we're going to do the same thing. We have the x value that is negative 12. So I take the x and I replace it with negative 12. And then I take the y value and replace it with 5. All I got to do is check to see if this is true or not. So there's my question mark over the inequality. Again, there's nothing I can do with the 5 in this equation, inequality. So let's see, negative 1/2 times negative 12, that'd be 6. 6 minus 1 is, well, it's 5. Now, the first part of this inequality, 5 is greater than 5, would be false. But the second part, the equal sign right there, makes this one true. So, since it's true for both, and technically we wouldn't want the equality because this is leading into something else. But since it's true for both, we can kind of say that this is a solution for both. So it's a solution. There we go. I guess I should have read the question. Would the ordered pair be a solution for the system of inequalities? This one, I guess, really should be yes. Whatever. This next ordered pair, it gives us a new x value that's 0 and a new y value that's -1. So once again, we're just going to go into both equations. I'll start with this. Y is less than or equal to -2/3 x minus 2. And I will replace the x with 0. And then I'll replace the y value with, looks like -1. And I will check for truthfulness. Now, again, it has to be true for both equations. So if I get a false statement on this one, then right away I would know that it couldn't possibly be a solution for the system. So let's see. -2/3 times 0 is 0, minus 2 is -2. So this would show that -1 is less than or equal to -2. Now, if these were positive, that would be a true statement, but since they're both negative, -1 is actually bigger than -2. Right here, we see that we have a false statement. So is the ordered pair a solution to the system automatically? We don't even need to check the other one. It's just no, it can't be. So, graphing systems of linear inequalities. In the past, we got to do this with one line, but today, we're going to have double the fun and get to do it twice. So the process, we look at it, we're going to graph each inequality like it is an equation. We'll do this one at a time. So you're going to make a line. You'll determine where the inputs and outputs are. That's just how you're going to graph it. The second part right here is, if you look, you should see either a less than or greater than symbol. If it doesn't have the equals, then you're going to have a dotted or a dashed line. If it does have the equals, like this one, less than or equal to, or greater than or equal to, then you get solid lines. The solid line indicates that all the points on that line would be true for that specific inequality. So again, we're going to do this once. We'll have the line on the graph, but then we're going to choose a point on either side of the line to test for truthfulness. And like I've said before, we're going to be using 0, 0. Because there, the x value is 0, the y value is 0. And when we're dealing with zeros, it's a very easy value to operate with. So that's what we're going to be choosing to use if we can. It's just, we need to remember, if it is a point that's on the line, we may not be able to use this one. So you got to choose a point that's not on the line, and we'll use 0, 0 if it's possible. Once we know if that's true or false, then if it is true, we will shade that side of the line. If it's false, then we'll shade the other side of the line. Because if that side is false, you can only have true or false. The other side must also then be true. Okay. Once you do this with one of the equations, you're going to go back up to the top. You're going to take the other inequality, graph it like an equation, determine if the line is dotted or solid, test the point. If you can test the same point, then you will. 0, 0. Check to see if it's true or false to shade. And the final solution is the area that is double shaded. So we'll have to look out for that. Okay? So here's our two inequalities. And I know you guys want to do this by hand. Some of you guys like doing it with slope and y-intercept stuff, which I'm also a fan of. But actually, I'm going to use the calculator. Okay? Because both of these are essentially in y equals format. Which means the first equation, I'm going to graph y equals -2x minus 2. And then the second equation, y equals 1/3 x plus 5. But again, notice that I've changed the inequalities. I don't have the less than or greater than symbols in this in either equation. That's because I'm graphing the line, which is where we get equality automatically and not the inequality. So when I go to my calculator, I just push the y equals button. The red equation will be my y1, and then the purple equation will be my y2. So I'm going to type these in. I'm going to start with y1, that's the red. It's -2x minus 2. Now I just go down to the second equation. 1 divided by 3x plus 5. So I've just entered both equations into the calculator. And since I have to graph this by hand, I'm going to need the table. So that's second graph. And then it shows me this table. But it has all my values for y1 and y2. Okay, so at the top you'll see this, and then it gives us these values. So I'll come back to y2 here in a minute, but let's just look at my y1 values, which are the ordered pairs. This would be 0, -2, 1, -4, 2, -6 for my first equation right there. All right, so I didn't have to do any calculating there. All I did was open up the calculator. I put these in, and it gives me these values. But I know I can put these on my graph. So I got 0, -2 to start out with. Then we got 1, -4, 2, -6, 3, -8, and then 4, -10. Now, if you wanted to scroll up in your table, which you can do, you would also get these ordered pairs. So -1, 0, -2, 2, -3, 4, -4, 6, -5, 8, and then -6, 10. So that is the line for y is equal to -2x minus 2. So I have all my points on my graph. What I need now is to determine if the line should be solid or dashed. Well, up here, I notice that we have the equal part on the inequality. Since it has an equal sign, since it is also equal in the inequality, this means that I'm going to have a solid line. Okay, so I'm going to take these points and I'm going to connect them with a solid line. Keep in mind also that on the assignment, you only need 2 of the points, and then it will graph the line for you. But you still need to be able to determine if the line is solid or dashed. So that's the line that I get for the first one. Now, where would the shading be? Because again, we're just going to focus on the line and the shading one at a time. Well, let's go back to the original inequality. So that is y is less than or equal to -2x minus 2. But as usual, since I can, I'm going to test the origin because the red line does not go through the origin, and that is at 0, 0. So that's an x and a y value. This is my test point. And the test point is to determine which side of the line I need to shade. So I go to this inequality that I've written up here at the top. Y is less than or equal to -2x minus 2. And since I've chosen the origin, that means that the x value is 0. And also the y value is 0. So, is that inequality going to be true or false? Well, this would be 0 is less than or equal to, well, 0 minus 2 is -2. 0 less than or equal to -2? No, that's false. Since it is false, the red line needs to be shaded on the other side. See how this point here is on the right side of the line? That means I got to shade the other side because it was false. At least for my red line, it's false. So I'm going to show the shading here. Something like this. Yeah, that's okay. Now, is this problem complete? No, it is not, because remember, we have 2 inequalities that we got to put on this graph. But the good news is, remember, I put this in the calculator already, so I've just got to put the values into the table. All right, there's my ordered pairs. Now, I don't really care about the decimal ones. I really like these ordered pairs in purple from my y2, my second inequality, that have whole values. So those are the ones that I'm going to put on the graph. Let's see where these go. So I've got 0, 5 to start with. That would be here. I've got 3, 6. So 3, 6. And then 6, 7. Now again, if you were to scroll down in that table, you would also get 9, 8. Or if you were to scroll up, you'd get -3, 4, -6, 3, and -9, 2, like this. So I've got these purple ordered pairs that I've just put onto the graph from my second equation, which I used purple for, right here. But now I've got to go and see, is this line, is the purple points, am I going to connect this with a dashed line or a solid line? Well, since the inequality has an equal sign right here, that means just like the red one, we're going to need a solid line. So, through this red line, the purple points, rather, all I got to do is draw this line. Okay, so that is the purple equation, the purple line right there. But I still need to test a point to see which side I need to shade. Well, this purple line is not going through the origin here at 0, 0, which means that I can still test 0, 0 with the second equation as well. All right, so there's my inequality, and I do need the full inequality now to test. But we chose the origin, which means we need to take that x, and in the origin, the x value is 0. But then the y value as well, we'll replace that with 0, because it's from the origin. And we're just going to test to see if this is true. So, this is going to show that 0 should be greater than or equal to 1/3 times 0 plus 5. 0 is greater than or equal to 5. That's false. So, since it's false, for my purple line, with my test point being, I'm going to say below it, right here. Since my test point is false and it's on this side of the line, I got to shade the other side of the line right there. So, let's get the shading. Something like this. All right, now this may be hard to see with a projection, but I can see that I've got cross-hatching right here. Otherwise, it's just regular lines, which I've kind of done that on purpose. And that means that the actual area that represents the solutions is this area. And that's it. That's all we got to do. This also means that if you were to take any ordered pair in this area, such as this point, which is -8, 4, if you were to test -8, 4 in both inequalities, original inequalities, you'd get true statements for both. If you were to test an ordered pair in the red area, just the red area, it would be true for the red inequality, but false for the purple one. If you were to test an ordered pair in the purple area, then it would be true for the purple, but not the red. And any ordered pair tested in this area would make both false. We need both of them to be true. So there's our two inequalities, but again, we're going to go to the graph on this one. And since we're doing it by hand, in the calculator, we need a table. So remember, up here in the top left, it says second, and then we're going to push the graph button in the top right. The reason that is because just above that in blue, it says table, and that's what we want. So we're going to graph these, but we need the table. So I'm going to make the red equation. I'm going to make this an equation, right? Because this is going to give me the line, and the line is going to be the equality part of this. So even though it's just a less than symbol, I don't care. I'm going to treat this like an equal sign, and then I'm going to put this into the calculator for the ordered pairs. Then I'll do the same thing with the blue one. Let's just start with the red one. So again, I put this already into the calculator, and then these are the values that I got. So let's just start with the red stuff. And the first ordered pair is 0, -4, then 1, -5, and then these other ones. So let's get these on the graph. So I've got 0, -4, which is here. Then 1, -5, 2, -6, 3, -7, 4, -8, 5, -9, and 6, -10. Now that's a pretty clear pattern for me, which means that I feel pretty comfortable just making the points, and some of you may feel comfortable doing that. If not, then on the calculator, you just need to scroll up in the table to find these other ordered pairs. So I'm talking about -1, -3, -2, -2, -3, -1, -4, 0, -5, 1, -6, 2, -7, 3, -8, 4, -9, 5, and -10, 6. So these are all the ordered pairs that I can fit onto the graph. Next thing I need is to determine if the line connecting these points should be dashed or dotted. Well, if we go back to the original inequality up here, we see that it's just a less than symbol. So there's no equal sign involved in the inequality. Since that is the case, this one is going to be a dashed or dotted line. So I put dashed, but these points are actually pretty close together, so I'm just going to keep it as is because that looks pretty good. Which means, in order to put the dashed or dotted line on the graph, all I need is arrows at the end. So there's my first line. So that's just the line that represents the equation from our first inequality, y is less than negative x minus 4. But I still need to figure out which side to shade on. So I'm going to use the ordered pair 0, 0 as my test point to determine which side to shade on for this inequality. So x is 0 and y is 0. That's nice. We want those to be 0 because 0 is a very easy number to work with. So we're going to take the original inequality this time. So y is less than negative x minus 4. But we just chose to test the ordered pair 0, 0, where the x value is 0. But the y value also is 0. So I take the y, I replace it with 0. And then I just check to see if this is true or not. So it'd be negative 0 minus 4, which is just 0 minus 4. That's negative 4. So it'd be 0 is less than negative 4. No, that's not true. That's going to be false. Now, since this ordered pair, I'm going to say this to the right of the line, is false, that means all these ordered pairs would be false for the red inequality, which means that we have to shade the other side of the line. There we go. So there's our red inequality. Y is less than negative x minus 4. But now we need the blue one. So that's y2. So I just look at my ordered pairs. That's 0, 4. That's nice because I can get that on the graph right now. 0, 4. Boom, right there. Next up, I don't really want to deal with 0.6 or 0.2, 0.8 or 0.4. So I'm going to go right down to 7, which comes from 5, 7. So that's the ordered pair. 5, 7. 5, 7 would be up here. Now again, if you were to continue scrolling up or down the table would give you 10, 10. And if you were to scroll up the table, you get negative 5, negative 1. And also negative 10, negative 2. So there's all my blue ordered pairs that I can put on the graph. Yeah, that looks okay. All right. So with this, is the line going to be dashed or solid? You got to go back to the original inequality. So the original inequality, it does have a equal sign. So since this inequality has an equal sign, we're looking at a solid line. That means all I need to do is take the points and connect them with a solid line. Put arrows at the end just to make it look pretty. All right, now that I've got the line, and this line is not going through the origin, this means that I get to test the origin again with this second inequality. So that's y is greater than or equal to 3/5 x, and then plus 4. But we're using the origin where the x is 0, and then the y value also is 0. And we'll check to see if this is true. Now, once again, if it is true, we'll shade that side of the line. If it's false, then we'll shade the other side of the line. But this one is going to give me 0 is greater than or equal to, that would be 3/5 times 0, which is 0, and 0 plus 4 is 4. So 0 is greater than or equal to 4. That is false. All right, so this ordered pair makes this inequality false, the blue one, which means I need to shade the other side of the line. So let's go and do that. I do this decently. I don't know why that was hard being left-handed, but whatever. Now this one is not showing a lot of the double shaded region, but I can still see it. It is this area right here. All right, so this one right here, that is the double shaded area. I can keep this red and then the blue shaded area. I just know that the double shaded area is the actual area with all the solutions. Meaning, once again, if you were to test any ordered pair in this area, then you would get true statements from both of the inequalities. You can test that if you'd like, but it's math, so I kind of assume no one really wants to. So we're going to graph these two inequalities. Y is greater than or equal to 2x minus 1, and then we got y is less than x minus x plus 2. Now, if you wanted to, you could simplify this second inequality right here. You don't necessarily have to, because all I'm doing is using a calculator to figure out the table for this. And since the calculator wants to do the work, that's what I will do. And then we will see what that looks like. Okay? So, just as usual, I'm going to go into the calculator. I'm going to push the y equals button in the top left. And I'm ready to put these into the calculator. So the first one I will do in red. And this will be my y1. Now again, I'm looking for the equality here so that I can figure out where the line goes. So I don't care that this is greater than or equal to. I'm just going to make it equal to when I put this in the calculator. And then I'm going to type in 2x minus 1. Once I get that in, and there's a minus sign, not a negative sign. But once I get that in, I'm going to go down to y2, and that's where I'm going to type in my second, well, it's an equation now. Now, does the calculator mind if it's x minus x? It does not. So thank you, calculator, for that, because it means I don't have to do as much work. But it's x minus x plus 2. And I can type that in. Some of you may choose to make that x minus x a phantom 0, which I would do. But let's say that you didn't notice that, and that's okay. You can. Okay, if I do this in the calculator, if I put these two in, now I can make the calculator give me a table. So in this table, it's going to give me a y1 set of values and then a y2 set of values. For now, I'm just going to focus on the y1 values, which comes from this red equation right here. All right, and that's going to give me some ordered pairs that I can then put onto the graph. So the calculator, my calculator is going to give me values from 0 to 6. And then let's see what values of y1 it gives me. But I got to actually put it into a calculator. Now that's a pretty good set. I don't see any decimals, so I should be able to put these all on, except the bottom there I got 611. That's just, it would be off the graph. So let's get these on there. I'm going to start with this first ordered pair. This is 0, negative 1. Then I'll get 1, 1, 2, 3, 3, 5, 4, 7, 5, 9. All right? So I go to my graph. I find 0, negative 1, which would be here. Then we got 1, 1 here. 2, 3. Again, it's always x and y, right? So you look at the x. Like the next one, I get 3, 5. So I just go 3 to the right, 5 up. So that gives me this ordered pair. And we got 4, 7, and then 5, 9. And again, that's all I can fit on this graph. If I were to go up in the table, it would give me even more values I can put on the graph, such as negative 1, negative 3, negative 2, negative 5, negative 3, negative 7, and negative 4, negative 9. So these are all the ordered pairs that I can put on the graph from the first equation, 2x minus 1, y equals 2x minus 1. And all these ordered pairs would make the equation true. But what kind of line will I have? This is where I got to go back to the inequality and see if it has an equal sign somewhere in there, and it does, right there. So since on this inequality we do have an equal sign, then we're going to have a solid line. Which means that I can connect all my points in red with a solid line. I put arrows on that, on the ends there, just to make it look pretty. Okay, like I was saying before, that was fun, and we enjoyed it, and our hearts are full. But we're not done. Because with this line that we've just put on the graph, we have to be able to shade either side of the line. And since we like to shade, we have to know which side of the line to shade. And this line is very close to the origin right there in green, but it's not quite on it. So that means I'm going to use an x value and y value of 0 to test in both in the first inequality. That's the one we're using, right? Y equals 2x minus 1. And then I will see if this is true. Sorry, not the equality, but the inequality. All right, so I'm gonna rewrite my inequality up here in the top right. It's y is greater than or equal to 2x minus 1. We are testing the ordered pair where x is 0, because it's the origin. So I replace the x with 0. And then I replace the y also with 0. And then I see if this is true. Now, if it is true, I will shade the same side of the line that the point is on, which would be this side. If it's false, then I'll have to shade the other side of the line. So I go back up here. There's nothing to do with the 0 there, but I can compare it now with the calculation of 2 times 0 minus 1, which would be negative 1. Now, as far as I know, 0 actually is greater than negative 1. It's not equal to, of course, but it is actually greater, which means that we just found that that ordered pair, our test point, made that inequality true. So, just kind of as a quick way to get this started, we'll just kind of shade this a little bit, just so we know that for the red inequality, we get shading on this side. Now again, it was because this ordered pair was true and it's on the left. If it would have been false, I would have had to shade this side. Now that I've done all that I can with the red inequality up here at the top left, now I'm going to look at my purple inequality. Y is less than x minus x plus 2. And let's just look at the ordered pairs that we get from the equation so that we can get the line on the graph. Now, if you go back to the calculator, it gives you 2, 2, 2, 2, 2, 2, and 2. Well, these are all ordered pairs that would be pretty easy to put on the graph, but you notice that y is 2. That's because the x's would have zeroed out, and then you would have just had y equals 2. So all the y's must equal 2 in order for this equation to be true. It doesn't matter what your x's are. Now we're still going to test the original inequality with both x's, but you'll see that it won't matter because we're testing the ordered pair 0, 0 when we get there. Let's get these ones on the graph, okay? So the first one, it says we got 0, 2, which would have been right here. And what do you know? This ordered pair that we just put on the graph, on the y-axis, it's where it's 2. Shouldn't be any surprises there because we've seen that before. But the next one also, we get 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. And if you were to scroll down that table, you would have gotten these ones. Or if you would have scrolled up, you would have gotten these ones as well. So I know I've kind of jacked up my test point, but I'm still going to use it. So we got these ones like this. Well, that looks pretty good. What kind of line will we have? Well, let's go back to the inequality up here. Y is less than. I'm just looking at the less than symbol right there. This one does not have an equal sign, so there's no equal sign. So this one will be dashed. Or actually, the way I have it, let me say that it's going to be dotted. Because I already got dots right there. Now, if I just don't connect those dots, then the way that this is right now, it's good enough. All I would need to add to the dots is arrows at the end. Okay, so there's the purple line from the second equation, second inequality. But now we've got to do some shading, and as usual, I'm going to test my origin, which is below the purple line. Again, if it's true, then I'll shade below. If it's false, then I'll shade above. Let's see if it is true or false. So we go back to the original inequality, which was y is less than x minus x plus 2. And I am checking on this one for truthfulness. Okay, well, we've chosen the ordered pair 0, 0, so my x's there are going to be zeros. And also the y value that we've chosen is 0. That's from the ordered pair 0, 0, the origin. Now we just check to see if this is true. This would be 0 is less than, well, 0 minus 0 plus 2 is 2. 0 is less than 2? Yeah, that's true. All right, so this ordered pair that we just tested, the origin, made this inequality true. Since it's true, everything below it needs to be shaded. So, I'll do this a little different, just kind of spacing out the lines. What we're looking for is the double shaded area. Okay, do we see the double shaded area? I see it. I hope you see it. I found it. It's right here. I'll try to make this look pretty. It's pretty colorful, so it's already pretty, but whatever. Okay, there it is. This is the area that I need to show is where all the solutions are. Again, all these ordered pairs in this area would make both this inequality and this inequality true. Again, if you're looking at this area, it makes this one true, but this one false. This area would make this one true and this one false. And this area right here makes both of them false. We need it to be double true in order to figure out where the solutions are. And we just found them. So the first equation there, y is greater than or equal to 1/2 x minus 6. Once again, I'm going to treat this like an equation so I can get the line on the graph. So I'm putting an equal sign here because I'm not worried about the inequality part of it, but just the equality so I can see where the line goes. It's going to be y1 equals 1/2 x minus 6. Now I'm putting the 1 here, it's y1 because that's going to be my y1 in the calculator. The second one, y is greater than x plus 3. Again, I'm going to look at it where it's equal to, so I know where the line goes, and then we can know that it's going to be dashed line because it does not have an equal to in the inequality. But that's going to be x plus 3. So I go to my calculator. This is going to be my y2. And I'm going to put these two equations into the calculator. And it will give me x values, and then it will give me corresponding y1 values and y2 values. We're just going to start by focusing on y1. So in my calculator, I'm going to put these in, and then when I do, it's going to give me x values 1, 2, 0, 1, 2, 3, 4, 5, and 6. But to put these in the top left of the calculator, I'm going to push the y equals button. And in y1, if there's anything there, I'm going to clear it first. But I'm going to type 1 divided by 2, x minus 6. And then for my y2, so I just need to go down, I'm going to type in x plus 3. So let's get that done in the calculator. Once I get those in, then I can type second graph and it will show me the table. On my calculator, this is what it gives me for my y1 values. So these are the values that it gives me. It does give me y2 values, but I'm going to come back to those because these are all ordered pairs. Now again, I don't really care about the decimals, but I can get the ones that are ordered pairs, whole values or integers onto my graph. So I'm going to start with that 0, negative 6, which would be right here. The next one that doesn't have a decimal, I got 2, negative 5. So I find x is 2, y is negative 5 there. So that's this ordered pair. And the next one, 4, negative 4 here, and then 6, negative 3. Now if you scroll down the table, you'll get 8, negative 2, and also 10, negative 1. If you were to scroll up the table, you'd get negative 2, negative 7, negative 4, negative 8, negative 6, negative 9, and negative 8, negative 10. So these are the ordered pairs that I get from my first equation here in red. Okay, so I'm color coding these. These red dots represent the ordered pairs that would make up the line for this inequality, or really this equation. Now that I have that, though, I need to figure out what type of line I'm going to be using. So I go back to the inequality. I see that it has an equal sign in the inequality. And since it has an equal sign in the inequality, this means that the line will be a solid line. So in connecting these points, I'm just going to connect them with a solid line like this. I'll put arrows at the end. and that is the line. Now that's just the line though. What I need next is to know which side of the line to shade on. So, as usual, I will choose the origin. So I go into the middle here. I've got, right in the middle, I've got 0, 0 for origin. 0, 0. My x is 0, my y is 0. And I'm going to be testing this origin right there, 0, 0. So I take the original inequality, and I need the inequality now for sure, but it's y is greater than or equal to 1/2 x minus 6. But we're testing the origin where the x value is 0, and the corresponding y value is also 0. And then we're just checking this for truthfulness. Okay, so this would be 0 is greater than or equal to, put this in the calculator, 1/2 times 0 minus 6, and you get negative 6. Okay, so the statement is showing 0 is greater than or equal to negative 6. It's not equal, but it is greater than, which means that we're looking at a true statement. So I'm back on the graph. This ordered pair, which is above the line, I'll say above, is true, which means everything else that's above the line is true. So I'm ready to start shading that stuff. So we'll just kind of give it a preliminary shading like this. I'm not going to shade it fully, but something like this, okay? Now, in the past, this was all we would need in order to complete the problem. But now, since it's a system, I've got to be able to put this inequality on the graph too. So I got to go back to my calculator, and then I'm going to see what it shows me in this column for my y2s. And that should hopefully give me some ordered pairs that I can then put on my graph. All right, there's my ordered pairs. Now, we're skipping the column, right? This is 0, 3, and then you got 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, and 6, 9. All of these are ordered pairs that I can put on the graph. So let's see, I got, let's put them on there. I got to start with 0, 3 in purple there. Then I've got 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, and 6, 9. If you were to go down the table one more point, you'd get 7, 10. If you were to go up on the table, you would get negative 1, 2, negative 2, 1, negative 3, 0, negative 4, negative 1, negative 5, negative 2, negative 6, negative 3, negative 7, negative 4, negative 8, negative 5, negative 9, negative 6, and finally negative 10, negative 7. It's a lot of points. But it's easy enough because we're just putting these on the graph and the calculator did all that work for me. I did not actually have to take these x values, plug them in, and then see what comes out. I did not have to do that. So I've got all my points on the graph. Now I just need to figure out if I need a solid or dashed line. And going back to the inequality, there is no equal sign here. It's just a greater than symbol. So since there is no equal sign, this is going to be I'm going to make it a dotted line because I've already got my dots there. But you could say dashed if you wanted. So I'm going to keep these dots the way they are. And to make this look good, I'm just going to put arrows at the end. And that's going to be my line right there. If they were spaced further apart, by the way, then I would be looking to combine them or connect them with dashed or dotted points. Okay, now that's just the line. What we need now is the shading. And the origin is not on the line, so I can use this origin to check for truthfulness. So we go back to the original inequality. Y is greater than x plus 3. And we're going to test the origin in here because it's not on the line. So the x in the origin, like we've already seen, is 0. And then the y in the origin is also 0. And I'm going to put a question mark over that inequality to see if it's true. So this would be 0 is greater than, that's 0 plus 3, which is 3. Is 0 greater than 3? It is not. This one is false. Since it is false, and on the purple line, the ordered pair from the origin is false, meaning I need to shade the other side of that line. So my purple line, I'll try to shade a little different. It's going to be this area right here. Okay. Well, where is it double shaded? Pretty easy to see there, hopefully the way that I have done it. But for now, it looks like it's just everything that's above this purple line at this point. Now, is it always just going to be above the purple line? No, because if we were to extend these two lines down here, eventually it would only be above the red line, but we don't get to see that far out. And it is okay that the two lines do not intersect. We're just looking for the intersection of the shaded areas. So that means everything in the shaded area would make both of the inequalities that we started with originally true. So you could try it. You could put 0, 10 in here and you'd get a true statement, or 0, 10 in here and you'd get this one as a true statement as well. And once again, we tested the origin. Remember, the origin made the red one true, but the purple one false. It was true for one, the red, like we see shaded, but it's not shaded purple because it was false for the purple equation. That's it. That's all we got to do. And since the calculator did most of the work for us, we can see it's not really that difficult, but you do have to have some idea of what to do. So for those of you taking a nap during class, don't expect this to work out for you, right? Or if you're going to mess around on your phone, that's okay, but don't expect to understand any of this garbage. There's our objective. I can solve a system that has inequalities. It's a lot easier to solve them, if you're going to pay attention, but we don't force you guys to do that because you're adults. You can make your own decisions like an adult would.